and proportions. And what we're going to do today is talk about similar figures, okay, similar polygons. Polygon is just a shape. And then we're going to translate that into similar polygons after this quiz. But this is the base of what we're going to be doing for the rest of this chapter, okay? So we need to make sure that we understand this. And hopefully this TV will work with me today. But we're going to start similar polygons, okay? Are polygons that have the same shape. Okay, same shape. It may cooperate with me. The first blank is supposed to say shape. I'm waiting on the TV to catch up. But it's going to be different sizes. Okay, same shape, but different sizes. Those are similar polygons. So, like, you could have two rectangles. They are the same shape because they're rectangles, but they're different sizes. Does that make sense? Polygons are similar if and only if corresponding angles are congruent. Okay, corresponding angles are congruent. And corresponding sides are proportional. That means we will be writing proportions, one ratio equal to another ratio. That is how we determine if polygons are similar or not. All of the angles must be congruent in each shape, and then the sides must be proportional. And to decide if our, to represent or to symbolize similar, it's going to be like this. It's that little squiggly line. Okay, that's what similar means. So we have congruent. You know how congruent is like an equal sign with a little squiggly on top of it? Well, similar is just going to be that little squiggly without the equal sign. The ratio of corresponding sides is what we call the scale factor. They use a scale factor a lot in like architecture, drafting. Okay, you make a miniature or something and then you make it to scale. So they have these scale factors. It's a ratio of your corresponding pieces. And then if polygons are similar, then not only are their sides proportional, but their perimeters are also proportional. What is the perimeter of a shape? The distance around the outside, okay, the perimeter, like your fence in your yard, it would be the perimeter of your yard. Everybody okay so far? All right, then we have what we call similarity statements. And a similarity statement must match corresponding angles and sides. Okay, we must match corresponding angles and sides. It's easiest to focus on the angles if we know which ones are congruent. Okay? If not, then we have to just really pay close attention to our side lengths in our shapes. So what we're going to do is we're going to practice writing a similarity statement based off of the picture there below. Okay, I have triangle ABC and I have triangle DEF. What we have to do when we write this is make sure that we put our congruent angles in the same position. So how do you want to call the small triangle? What order do you want to put those letters in? CBA. All right, so we'll call it triangle CBA. Okay, you got to put that triangle symbol in front of it so I know you're talking about a triangle. And then we write the similar symbol. And pay close attention to your picture. What angle is congruent to C? That's the one we have to list first. F, okay, so we're going to call the next one triangle F. And then we did B, so what angle is congruent to B? E. And then the last one would be angle D, okay? So it doesn't really matter the order in which you list the angles as long as they're the same. So wherever C is listed in your first triangle, then F is going to have to be listed in the same position. Wherever B is, E is going to be listed. And wherever A is, D would be listed. So if I called it A, B, C, then the other one would be D, E, F. The congruent angles have to be in the same position. Everybody ready? Understand? Questions? All right, so what we're going to do is we're going to look at the figures. And it gives us a similarity statement. Up at the top in the examples, it says ABCD, that's polygon ABCD, is similar to PQRF. So what we're going to do is we're going to list all congruent angles, and then we're going to write a pair of proportional sides. Okay. We can do that not necessarily on how the picture looks, but how my similarity statement is written, okay? So your similarity statement is this piece right up here. So I'm going to start with angle A. What angle would angle A have to be congruent to? Angle P, yep. Because A is listed first in the first figure, P is listed first in the second figure. What about angle B? What would that have to be congruent to? Angle Q, yep. What about angle C? Angle R, yep. And then angle D would have to be congruent to angle S. Okay, listed in the same position. That's how I'm telling this. My pictures are twisted and turned, so I can't tell just by looking at the pictures. I have to use my similarity statement to determine which ones are congruent. Everybody ready? All right, and then to write a proportion, there are multiple proportions we could write. We're just going to start by picking a side. So let's say we choose AD. Okay, so segment AD over what I have to figure out is which segment is in the same position in the other figure. You can't necessarily always look at the picture and tell. So what I'm going to do is look at my similarity statement. If I chose AD, that's the first and the last letter in my similarity statement. So what segment would be in the same position in the other? PS, yes, the first and the last. So what we're going to do is we're going to put AD over PS. And then I'm just going to pick another side out of my figure. It doesn't matter which one. Let's do DC. Okay, DC has to go on top because it is in the same shape as AD. And what side would be in the same place as DC? Look at your similarity statement. What two letters are in the same place as DC in the other figure? SRRS. It really doesn't matter which way you call it as long as it has those two letters. That means the lengths of my sides are going to be proportional. If I actually had lengths here, I would cross multiply and those would be equal to each other. That's what proportional means. Everybody understand? Okay, try the next one. Do exactly the same thing. List all of the congruent angles and then give me one proportion of sides. Listing all of our congruent angles based off of your similarity statement for that second example. And then you're going to write a proportion of sides, just like we did for the first one. Sometimes your shapes are drawn in exactly the same direction. And it's easy to tell, but a lot of times they're going to twist and turn them. So you need to pay attention to your statement.
Hey, did you go to the game, Super Bowl State? I don't know why. Jeremy came, bro. He had like 25 in the first quarter. And he did like, I think, 35. Florida State got good, bro. He's got that number 2.
We're listing our congruent angles and a proportion with our sides. What is angle N congruent to? Okay. What is angle P congruent to? Okay. Angle Q is congruent to? And angle R is congruent to? T. Anybody have any questions there? All right, I need a proportional side. Give me one side in the first figure. NP? Okay, so we're going to look at NP. And again, that's the first and the second letter. So what's going to be in the same place in the other figure? Which one, the first two? V, U, U, V, either way. Okay. Now, pick a different side in the first picture. RQ, okay. And that's going to be in the same place as what two letters? RQ are the last two. What are the last two in the other one? Yep, TS, ST, either way. It's talking about the same segment. And we're just writing proportions. And we will actually use them to find side lengths later. But we need to get in the habit of how to write these proportions based off of my similarity statements. Anybody have any questions? All right. Let's skip over that example because it's the same thing. I want to move on to scale factor. So the example that's at the top of the page, we're going to just skip over that for right now because it's exactly the same thing as what we just did. Okay, so at the top of the page on the back, we're just kind of skipping over that. We're going straight to where it says scale factors. Everybody ready? All right, first of all, with the scale factor, the order in which you write it matters. Okay, order matters. Meaning, whichever one you write first matters in how you use this scale factor. A lot of the times, you're not going to be told how to write it, especially like in books like this. I usually go from left to right. For me, I'm going to tell you which order I want you to write it. Left to right, right to left, big to small, small to big. Okay, so pay attention to what I'm telling you. So what we want to do is we want to write the scale factor of triangle ABC to triangle DEF. We have to make sure we are listing a pair of corresponding sides. Do I know all the side lengths in both of my triangles? Yes. So this is what I usually do. If I am given all of my side lengths, I usually pick, if all three of them are given, the smallest in each triangle, okay, or the smallest in each figure. Okay, the smallest goes with the smallest, the largest goes with the largest, and the middle one goes with the middle. So if I'm looking at triangle ABC, what is the length of the smallest side? 8. Okay, so I'm going to go 8 over. Scale factor is written as a ratio. We're going to write them as fractions because we're going to use them in proportions. And what is the smallest side length in triangle DEF? 12. Now, what did we talk about ratios? We said they always have to be simplified. What number can 8 and 12 both divide by? 4. So my scale factor simplified is going to be 2 to 3. You will be asked for the scale factor on your quiz. You need to make sure you are listing the correct sides together and that you reduce it if possible. What changes about the next question? What does it say? DEF to ABC. So that means I want triangle DEF first and ABC second. Let me ask you a question. Did we already write the scale factor from ABC to DEF? So if I need to switch it, what do you think I should do with that scale factor I already wrote?
Just switch it.
Just switch it. Put the 3 on top and the 2 on the bottom. Okay. I'm using the same 2 triangles. I'm using the same sides. I just want to switch them. I want DEF first and ABC second. The order matters here. Everybody ready? Sure. Okay. How do you find the perimeter of a shape? Oh, come on. The distance around the edge. How do you find it with your side length? What are you doing? All right, what are the side lengths in triangle ABC? What are the numbers? 18 and 18. If I want to find out how far it is all the way around that triangle, what do I do with those numbers? Add them. So I want you to add 8, 10, and 18. Find the perimeter of triangle ABC. Then I want you to do the same thing to triangle DEF. Add all of the sides of ABC, tell me what that perimeter is. Then add all the sides in triangle DEF and tell me what that perimeter is. What is 8 plus 10 plus 18? 36, okay. And then do the same thing for DEF. We're going to add 12, 15, and 27. What? 54. How is it asking for my ratio of perimeters? Which one comes first? DEF? Okay, so we're going to write our ratio. 54, DEF, perimeter, over the perimeter of ABC, which was 36. Do you guys remember how we talked about simplifying ratios or fractions in our calculator? If you don't, open up the calculator. Type in the number 54. Then you hit your fraction key. Then you type in 36. And you hit equals. And it's going to give you something that looks like this. Is that what you get? Okay. But remember we talked about how to change this. This is a mixed number. We want to change it to improper. So hit your second key. Then hit your fraction key again. And then hit equal. And that will turn it into an improper fraction for you. What is it? 3 over 2? Yep. And then 36. We got 3 over 2, right? What do you notice about the ratio of the perimeters from DEF to ABC and the scale factor? They're the same. What do we write right here? Oh, it's coming. Sorry, you got to let my... If the polygons are similar, their perimeters are also proportional. That means the perimeters will reduce the scale factor, or the ratio of the perimeters always reduces to be the same thing as the scale factor. If you don't remember it, you can figure it out by adding all the sides and writing the ratio. However, if you remember, once you know the ratio, and if they ask you for the ratio of the perimeters, all you have to do is write the same thing. Make sense? Okay. Okay, first things first, we are going to determine whether quadrilateral ABCD, it's coming, is similar to quadrilateral EFGH. Okay, if so, we're going to find the scale factor. If not, we just write it up. So, look back at the top of the first page. What two things have to happen? All of the corresponding angles have to be what? We wrote it right under theorem 8.1. All of the angles have to be 1. Look at your paper. What do we write? Congruent. Are all of my angles in the first figure the same as the angles in the second figure? Yes. How do you know? What are they all marked? Hold on.
The alphabet's different. Yeah, they don't have that.
Oh, y'all don't have the same alphabet?
W, X, Z, Y, S, P.
What in the world? Oh, I must have skipped this one. All right, well, y'all just pay attention to this one because this one's easier to determine, and then we'll look at the other one. I'm sorry. I don't know how that got left off the notes. Can everybody see this picture? What kind of angles are marked for all 4 angles in each of my figures? Right angles. So first of all, my angles are congruent. Then to determine if they are similar, we are going to have to see if my sides are proportional. I'm only given 2 sides though, right? Okay. What's the shorter side in ABCD? What's the side length that's shorter, 8 or 10? 8, okay. Over, what is the shorter side in the other figure? 12. What I'm going to do is I'm going to make a proportion and see if it's true. What is the longer side in ABCD? 10. And then the longer side in EFGH? 14. Is everybody understanding what I'm doing? I'm just trying to see if this is a true statement. Small over, small on the left, small on the right, big on the left, big on the right. Do me a favor, cross multiply. Do 8 times 14. Tell me what that is. We're multiplying 8 times 14. 112. Okay. And then do 12 times 10 for me. Are those equal? No. That means my sides are not proportional, so these things are not similar. If those 2 numbers had been equal, then we would say that the sides were proportional. Does that make a little bit of sense? Okay, sorry I left that one off of there for some reason. I don't know why. It's a mistake on my part. All right, let's look at the other one now. Now we got WXYZ is similar to PQRS. It's telling me to find the value of Y. So what we're going to do is we're going to set up a proportion to our corresponding sides. And then we are going to solve for Y. So let's start with where Y is. Y is right here, 5Y minus 2. What is the name of that segment? What 2 letters are at the end? ZY, okay. So what is in the same position as ZY but in the other figure? RS. So what we're going to do is we're going to write our fraction with those 2 side lengths. So I'm going to go 5Y minus 2 over 6. I'm going to make that equal to, here's the key when you write your proportions. I started with 5y minus 2, which is in this figure. So in my other ratio, I have to use a side length from this same shape. What is the only side length that I have? 16. Okay, so 16 is going to go at the top right there. And then the 6 came from this shape over here, so my other number is going to come from here. What is the only other number that I know? 12. Okay. What we do have to do is make sure they're the right sides, which in this case they have to be because they're the only ones that I was given. Anybody have any questions so far? How do we solve proportions? Cross multiply. So let's start. I want to multiply 12 times this whole thing. So I want you to do this. I want you to do 12, parentheses, 5y minus 2. Put an equal sign. And then what is 16 times 6? Multiply the other diagonal. 96. What I want you to do is solve that for y. Distribute your 12. Everybody should be distributing their 12. What is 12 times 5? 60. And then 12 times 2 is 24. Then we're going to continue to solve this equation for y. What do I do next? Not subtract. Add it. So 60y equals, what is that going to give me? 120. And then we divide by 60. And so y is going to equal 20. Anybody have any questions? It should be 2. I can't do division in my head apparently. Thank you. 2, not 20. Don't trust me always. I make mistakes. Do the math yourself. Anybody have any questions? So you're going to use proportions a lot with similar figures. You're going to set up proportions, you're going to cross multiply, and you're going to solve. Another way that we can solve it is if we're given the scale factor. Read the question. If the figures below are similar, what does it tell me they have? A scale factor of 2 to 3, and then it specifically tells you from left to right. That means the left figure goes first, the right figure goes second. My scale factor, what does it say it is? 2 to 3. So I'm going to write my ratio of 2 to 3. You can always use the scale factor to simplify and solve for missing pieces. How do you think my other fraction should look if my scale factor is from left to right? What is the side length in the left picture? 42. What is the side length in the right picture? X. Okay, you have to listen to what it says. If it doesn't say, you always just assume left to right. Okay, but I will always make sure I specify for you which one you're looking for. Cross multiply and solve for me. Figure out what X is. Cross multiply multiply and solve for x. We're going to multiply 2 times x. Set that equal to 42 times 3, which is what? 126. Then we can divide by 2, and what'd you guys get? 63. I did not update my notes, I think is what happened. I updated y'all's notes and didn't update mine. Okay, we're going to skip my example because I don't have what y'all have. Y'all have some true-false questions next, yes? All right, these are important because you're going to have some very similar to these on your quiz on Thursday. What does the first one say? All squares are similar. Same size, different shape. Would my would my angles be congruent in both squares? No matter what, yes. Okay. Would my sides always be proportional? Think about this. Let's say I have a square and each side length is 4. Okay? And then I have another square. Aren't all of the sides the same in a square no matter what? So let's say these are 11. Would this over this always be equal to that over that? Okay. So would all squares always be similar? Yes. Okay. That's true. All squares are always similar because one square has side lengths of one number, the other one has all the side lengths of another number, so those are always going to be proportional. Next one is kind of tricky. What does it say? All triangles are similar. What's your first guess? I heard both. Okay. Most people say yes. They think all triangles are similar because you say a triangle is the same shape, yes?
Yes.
Is this a triangle? Is that also a triangle? Are those the same shape? No. So, are all triangles similar? No, that is false. Okay. If I were you, I would write these down. You're going to want to say with these. What's next to say? All circles are similar. What do you think there? Yes. You can't have two different types of circles, can you? You have different types of triangles, isosceles, equilateral. You have obtuse and acute. Okay, you have different types of triangles. You do not have different types of circles. Ooh, next one, also tricky. All rectangles are similar. Okay, now let's talk about why. The circles? Yeah. Okay, a square looks like that, yes? But isn't a square also a rectangle? So you were right. This is not similar to that, right? It is not the same shape. A square is a rectangle. A rectangle is not a square. However, if I just say, are all rectangles similar? No, because some rectangles can be squares. So that's going to be false. Make sense? Now, these next two, do not confuse them. The first one says, if two polygons are congruent, what does that mean? They're the same, right? If two polygons are congruent, then they must be similar. What do you think? True. Okay. Congruent, same size, same shape. Okay. When you say similar, they have to be the same size. They could be different shapes, but they could also be the same. So that one is going to be true. And then what about that last one? It says if two polygons are similar, then they are congruent. No, that is false. Okay. So be careful in the way that that is worded. One of them will be true. One of them will be false. You will have questions very, very similar to these on your quiz there. Anybody have any questions? All right, we